costly G fixes are not required. These G fixes are also will be unknown to you. In earlier case, I was referring to the large scale production, same item in large scale. Quite often in mechanical items, see a French type of this. The number of drill holes you have to carry out. So this is a very common item. So on this type of item will not be manufactured only 1 or 2, 100,000 will be manufactured. So in that case, that means there is a pattern that these 5 holes has to be carried out. How will ensure that the holes are carried out exactly at correct location? We have to go for some marking tools, very fundamental. Give a chalk mark, take some marker, make a punch, then carry out the number. So for one job it may take 20 minutes, 30 minutes, which is not economical. So in that case, earlier I have to come earlier practice. So you prepare one template where these standard hole locations are there. So when this template is available, now for the over the raw material you put it, which has already got the 5 standard hole. Now you bring the drill bit exactly at the center of the drill hole location and push it at the top. So this initial item and to guide the tool, jigs and fixtures are required. Okay, that is traditional. But when NCCNC came into existence, we no longer require this jig and fixture because it is programmable. So if you consider this is your job, and just imagine that this is a graph paper. So if it is the origin here, so easily you can find out what is the prominent part of this part. Let's say 15, this is 20, this is x40, this is 20, this is x20, this is y40. So simply mathematically you can specify the whole center location, and the tool will correctly move to that location. Then just simply allow it to penetrate. That is what cause these fixtures are not required. High accuracy and reduction of possibility of scrap will be reduced. Speed operator is not required because machine itself is intelligent and less floor space. Here, less floor space does not necessarily mean the machine is very compact or can be mounted on the table. That is not the idea. Idea is that one machine can carry out quite a good number of operations, which otherwise would have required more than one machine. So instead of having 2 different machines, the whole category of operation can be carried out in one. So that is how your floor space can be used. And the major efficiency was at that time no memory, so programs cannot be stored. Unreliable, editing is difficult, and complicated profile is difficult to generate. The profile that we are generating right now, like this way, so it requires your interpolation. I will come to the interpolation today. So since the computation facility is not available in the IC system, so it is very difficult to identify the closely spaced points manually, which is really tedious and time consuming. So that is why it was not very attractive. So what is CNC? What is the advancement of the modification? It has got a dedicated store program computer to execute all the CNC functions, and importantly, it can save the program permanently. And due to your high speed computing facilities, these internal calculations can be carried out very fast and of course accurate. So advantage is the presence of dedicated computer helps to store part program. Complicated calculations can be done and therefore complex shapes can be generated. So it is a computer that is responsible for undertaking all sorts of calculations, and that is what makes it possible for complex shape generation. Graphic display. So how the tool is moving, actually you can also visualize in a graphic platform. That is not only a question may arise in your mind. So since the job is already being executed in front of you, then what is the necessary to see the graphic display? It is basically required to for the program coding. In case of manual program, there may be possibility that there is some syntax error, there may be some typing error. So how you check that? In case of it is not like your conventional C programming or Java programming or MATLAB programming that you will run, and if you find some error, you can rectify it. But here, running means there will be physical contact between the tool and job. So if there is an error, there will be catastrophic failure. There may be accident which can damage your costly machine in the tool, and it can also cause damage to the operator. So to prove the program, to find out any deficiency of the some syntax problem or error, you can run it in the graphic system. So the same toolbar without any physical movement, it will move or it will replicate the program of the toolbar in the graphic. So therefore you can see if there is any some error or mistake in your program that you can rectify before real life or real implementation. What I am referring to the CAD integration, so that is giving the added advantage how design activity and manufacturing activity can be clubbed together to reduce the time. These are some of the added advantage. One is adaptive control system can be installed. What I was referring to unofficially, that is regarding the cyber physical system. At that time, the concept of cyber physical system was not there, but with a separate software, the same optimization approach was implemented. That is, programmer can, according to his or her experience, he can follow some orthodox or conservative levels of speed field. There should not be any much vibration, there should not be any damage, there should not be very high force. But it is not optimum. So if you have some sensor installation facility where the process data can be acquired by the sensory system, and with the help of the software, it can be analyzed and modified course of process variables can be find out and can be implemented in the controller. So that's automatic or the self adaptive means self without any external intervention. So machine with that adaptive control software will be capable of taking corrective action to optimize the process. Automatic diagnostics. Some features is also available in the CNC to diagnose the machine problem. Macro programming, it is a higher order programming facility. Here we explicitly specify the what is called your dimensions or the coordinates. But if similar type of jobs need to be carried out, where their relationship will be remain same. Just for instance, again I am coming to this one. So this is one block having some specific size. Now just we scale it up 3 times. So I would like to maintain the same proportional gap in the new job. So in that case, instead of specifying the exact value, so in case of one job, this particular job, one particular distance required is 10 millimeter. So if it is 3 times magnified, the same distance should be 30. So instead of specifying 10, 30, 20, I introduce one relational approach. The distance between two holes is 3 times of this, 3C or something like that. So wherever the dimension of the basic plate will change, this gap between the two consecutive holes will also change automatically by the relational parameter. I can also define CC plus standard 10 millimeters. A small mathematical concept. So that type of possibility is also there. That is called vector programming. Relational automatic tool monitoring system is what I am referring to. That if you when the tool is engaged in cutting, it is very difficult to identify what is the magnitude or amount of wear that has taken place. Where you will replace. Suppose you buy a new blade and go for saving. One blade will give you 3 cuts or 4 cuts. So how will you feel? Will you be able to measure what is the level of wear of your blade that you are using? So what is the experience? You experience that you need more force to cut. That is, so when this force you feel through your experience that it is a bit increasing abnormal, then you replace it. So here also it is very difficult to measure the magnitude of wear. When to replace the old one? Okay, so automatic tool monitoring system, that is another additional accessories that is also available in the market. If you install, then that system will be capable of monitoring this tool wear. If you identify, there are a lot of techniques for measurement. Say wear level will be 0.5 or 0.3 millimeter. So when the actual wear will be 0.3 or more, there will be some alarm signal. That means it will bring the attention of the operator that it is the high time to replace the old one by it. So this sort of lot of added features are available in the CNC. This may be a little bit interesting for you. We had operated in the CNC machine router. In the machine, in the second half, you please notice that whenever we specify any values x, y, z for you, so it is mandatory or very imperative that at the very beginning you have to identify the axis nomenclature. So here, z axis is the first, the most important. Z axis will be always along the spin. In the second half, if you visit there, you will find that the red color mark is there. Z plus Z minus along the spin of B. Now, movement, up down movement. Okay. So how to define what is plus and minus? So Z will be the axis Z axis, which will be always along the spindle. In any case, if the spindle remains horizontal, then this will be Z direction. In this case, cutter is vertical, so this is Z direction. Now regarding plus and minus, our job is here, cutter is here. If the cutter, so regarding plus and minus, if the tool goes up, then the distance between the tool and job increases. So that is plus. That means when it comes down, that means when it is taking part in cutting, tool is moving towards the job, so that will be minus. So that is how you have to establish. We cannot change. I wish that instead of this is the Z direction, I would like to define or follow. This will be the Z. That is not permissible. Okay. So gear movement is always around the speed. And regarding x and y, it is just in the horizontal table. So the conventional right hand coordinate system is x is along this direction, y along this. But what I can remember, I feel in this machine, the router, this is around x. Actually, the longest distance is considered as x from the manufacturing of the business of the industrial perspective. They usually consider x, which is the longest travel. So in that case, this will be x, this will be y. Okay. Other what I am discussing. This is just the fundamental way to classify based on the how much different how many different steps can be applied. This is popularly known as your type of interpolation facilities are available. And if you our objective is basically to generate different complicated shapes. So these complicated shapes of the profiles can be subdivided into lot of fundamental categories depending on their similarities. But out of this, in any conventional CNC machine, C modes are prominent or available. If you go for the higher level, then you have to go for the other category of machine which are very special. Usually point to point, straight line and circular interpolation. These three are permissible. So based on that, it is classified on the positioning system. The very first one point to point and the continuous. Whenever I was referring to that drilling operation with holes. So when the tool comes to this, suppose this is the tool pitch, it comes exactly over the, of course it will be the vertical plane. So when the tool is brought exactly to the drill center point, then it moves downward according to the depth of penetration. Okay, so the tool moves its space to reach a accurate point which is defined by its coordinate. So this movement is called point to point. The path is not important. The correct location of the drill center point, that is important. So that is why this sort of positioning system is called point to point. In contrast, in all other categories, motion is continuous. Be it straight line, be it circular, whether it is parabolic or any other profile, it is continuous. So in one hand it is point to point, other way it is continuous. Now within the continuous segment, there may be two variants. One is paraxial and another is contour. In the paraxial, the very name implies the movement of the tool will always be parallel to any of the axes, either be parallel to x or parallel to y. No combinations is there. So that is the paraxial. But for complicated shape, it requires combinatory motion. That is contour motion. Milling is a mechanical example. That operation which you are carrying out in the CNC router or PCB milling, they are called basically milling machine. And in entire contour control can be subdivided again. It can have 5 different variants. These two are popular and which are also available in the machines available in the ideal lab, that is linear and circular. So if you write chemistry depending on the font, so C means basically an R, okay, C H basically straight line, E basically straight line, M basically straight line, R some portion straight line, some portion R. So apparently it looks complicated. Even all over the majority of the mechanical components that we encounter, if we visualize in that perspective or decompose into fundamental geometrical entities, you will find these are either straight line segment or circular arcs. So that is why these three types of interpolations are usually implemented. Other complicated for helical, cubic, parabolic. So, for example, aerofoil profile, turbine blades. This cannot be captured or cannot be represented by your standard mathematical equation. So in that case, we call these free-form surface, where Bezier curve or spline, nerve surface. These falls under this free-form surface. They are so complicated. These are mathematics because they are also used for approximation purpose. Exact path is very difficult to handle. So in that case, we require CAM software. Manual calculation is next to impossible. Okay, but still, if you want to go for helical, cubic, parabolic profile generation, through software is possible. So anyway, there is the spectrum of classification. This should be, of course, only for theoretical work, just to understand how the operation or activity takes place. So through any input device, maybe computer or maybe in the earlier case floppy disk. So you prepare the program, keep it ready. So this input goes to the machine control unit. This machine control unit is the brain of the machine, just similar to our human. So all the intelligent decision making functions are taken care of by the machine control unit. Now this MCU has got two parts. One is data processing unit, another is the control loop unit. Again, within this DPU and CPU there is a hierarchy. DPU is the higher level. All decisions, calculations, these are taken care of by the DPU, and instructions are sent to control loop unit for its implementation. Okay, so entire logical decision or calculation, everything is taken care of by the machine control unit. So machine control unit will retrieve the data which we write in the high level language. That will be converted to the machine language, that is the binary, and it will be interpreted by machine control unit. Now this process data is required to be implemented for movement for the running purpose. In a full motion data is sent to the drive system, which will be executed over here. So this is just see is the horizontal table. So that this table will have XY or the horizontal motion. Okay. And this rotation, what I was talking about. So that you see here as a mysterious function. Because rotation falls under the category of spindle rotation falls under the category of mysterious function. So that information at what RPM this spindle will be rotating, that is sent to the desktop. Another thing is that all these machines basically works on or relies on the principle of closed loop control system. That is to improve the accuracy of the machines. Whatever is carried out, that is a very significant and fundamental part of any control system. Unless there is monitoring and steady corrective action continuously, it is very difficult to ensure accuracy level. Say for instance, you have told me, sir, you move by 10 meters in this particular direction. Now, you told me to move in this direction by 10 meters, but by mistake or intention, what am I doing? I move in that particular direction. I start moving in that. So how to correct me? Only thing is that if you monitor me, instead of going in this direction, you are moving in the wrong direction. So you monitor and give me instruction, don't move in that direction, rather take 130 degree turn and move in this direction. So this monitoring and corrective action, then and then only it is possible for myself to move exactly by 10 meters along the desired direction. Same logic goes to in this case also. So if in a program line, if I specify or the it is if it reads like just 50, get 50 or y 50, it has to monitor that it is moving exactly along that particular path. So for that, there will be certain feedback devices. Now here, two aspects are involved. Whenever I move or we move or even a non-living system move, two parameters are involved. One is correct end position, which is called position or displacement, and the rate at which I am moving. This is also important. So this rate at which I am moving, that is related to the feed that I have specified talking about in the question video. So this feed movement is also very significant in case of our metal cutting machine. Okay. So the monitoring of the movement of speed and the exact specified displacement both are required to be observed or monitored and corrective actions to be taken automatically, continuously, so that eventually the slide will move up to the desired distance following the defined speed. So for this purpose, two different transducers are required. One is called position feedback device, another is called velocity feedback. Velocity feedback is normally taken care of the tacho generator, and feedback may be linear scale based on the wire fringe pattern. It may happen, or another popular device is encoder. That is a circular disc having some binary mark 01, 01, actually not 01, transparent and opaque region. In one side, some light sources are there, on the other side, photocells are there. So when transparent region comes in front of the light source, light will pass and photocells will be energized, so this pulses will be everywhere. When it is opaque, no pulse will be, no voltage will be coming. So again, it is 01, that is binary. So that pulse stance is related or counted to identify what is the area. So anyway, the principle is basically, so once you start moving, this feedback device will start monitoring the velocity and instantaneous position and give a feedback to the control loop unit that this much is still left. If you tell me to move by 10 meter, say I have moved by 0.5 meter, that means 9.5 is still new, another 0.5, 9 meter is still new, 1.5, 8.5 is still new. That means continuous feedback and how much is left, this is popularly known as error signal. What is actual and what is reference. Reference is 10 meters and instantaneous is 0.5, 0.5, 0.5 I am moving. So that distance will be sent and the system will calculate the reference as 10 minus 0.5. 9.5 is due. 10 minus 1, 9 due. 10 minus 8.5, 1.5 due. 10 minus 1, 9, 1 due. Likewise, when the due of the error will become 0, it will stop. That implies the execution is common. So this is how the system works. So that is what exactly is taken care of in this. So intelligent function is taken care of the system. This is the way of programming. It is very simple. In one mode, I was referring to this coordinate value x, y, z, whatever it may be. There must be some reference to the origin. In absolute mode, the origin remains fixed. The way we follow in our graph paper system. So that is 0, 0. Point P1, say 10, 20. Point P2, 30, 40. So all points are basically specified with respect to fixed origin. But in case of incremental, first you identify a point having coordinate 10, 20. For the second point, first point becomes origin. Similarly, for the third one, second point becomes origin. So this sort of origin changes dynamically. That is called incremental mode of programming. To the sum of the mechanical components depending on their drawing dimensions, sometimes this may be useful, sometimes this one may be useful. And it is the wish or the prerogative of the user or the programmer. He can of anyone with the appropriate G codes, and even he can toggle. Not necessarily once you have started writing the program in the absolute mode, you cannot switch over to the incremental. There is no such restriction. But with program code, you have to switch to the incremental, and again you can also come back. So at any number of times you can toggle between these different approaches to the program. This just expressed in a very simple way. What I was referring to as control loop. There are two categories of loop. One is open loop, it is called closed loop. Open loop is not that much sophisticated. It is as such not used excepting for some lab purpose or from say toys which do not have require that much of development use. Just in a sub context you can see there actually there is no loop like this one. There is no such loop. So there is no monitoring, no feedback, no corrective action. So whatever dimensional values of program system will implement, but the perfection of the whether there is any error or not in execution, that neither can be sensed nor any corrective actions can be taken. And component wise, the main motor of the drive is stepper motor. There in this side is not shown. There will be pulse generator. So there is a lot of calculation part of there. I am not going to that, but detail. Whenever you write a particular value, say allow x, the required displacement should be 40.8. So for 40.8, how many number of discrete pulses are required? That the machine control unit will calculate. It is not my responsibility, not your responsibility. The system will calculate automatically. But once it is calculated, so series of power strain will be supplied or transferred to the stepper motor. And stepper motor will keep on rotating. This part is purely mechanical. Through a gear box, usually the speed of the motor is reduced. Okay, so a reduction gear is required. This is what exactly the reduced. Just like our nut bolt system. So when this screw rotates, what the screw there is a nut and what the nut there is a table. So table will also have a linear movement. So eventually rotary motion is converted to linear motion. Because XYZ motion is fundamentally the linear motion. So rotary motion is converted to the linear motion. And in case of closed loop control system, it is a little bit sophisticated. To calculate what I was talking about, this error will be equal to your program value or the reference value minus actual value instantaneously. So there is a device, electronic device called comparator. Electronic people know better than me. Anyway, just I can tell you only the function. There are two counters. In one counter, which is identified as a plus counter, where your reference value will be stored. So if my result is the 40.8. So that value will be stored in the positive counter, and the instantaneous value or actual value as measured by the position sensor that will be fetched back to the negative counter. And this actual value will always keep on changing, and based on that, comparator will calculate the error signal. That is what is the D? The reference minus actual, and that error signal will continuously give signal the DC servo motor. This stepper motor is replaced by the servo motor. This servo means sense and act continuously. So on this side you see this is same mechanical part. Only thing feedback devices are installed to complete the program. And another item you can find DAC, that is digital to analog converter. Because all these calculations carried out in machine control unit in digital mode. But this servo motor requires continuous analog voltage. So another digital device that is digital to analog converter is installed. Another thing I have missed over this particular diagram, that is for one amplifier is required for amplification of the signal. That will be visible. The same thing with a little bit of modification or enhancement, where two different loops are there. One is velocity loop, another is position measurement. As I told, position measurement as well as velocity measurement both are required. So velocity measurement is taken, velocity part is taken care of by this loop, and position feedback is taken. These are not going to that part. That is the calculation part. One thing is that the resolution, what is the minimum incremental movement that is possible to increment. Suppose I specify 40.8. Your requirement is much more precise. 40.800. Whether this 0.002 see, that particular machine will be able to accept an increment. It is much finer, much accurate. So what is that minimum incremental value? Whether 0.01 or 0.1 or 0.05, this minimum incremental or decremental value which the system can understand and interpret, that is known as the resolution, or sometimes called basic length unit. That's similar to our micrometer or vernier caliper. It is analogous. The discount is mentioned. So below the discount you cannot take any reading. So that concept is very applicable in case of NCCNC, which is called resolution. The resolution can be expressed in two ways. One is mechanical resolution, which is called P by LS into RT. This P is basically each of the needs to, that is for one turn, one complete revolution of the your mold or screw, what would be the linear movement corresponding. That is called pitch. LS is the number of steps in the stepper motor, and RT is the action the one gearbox. So there is a gear ratio. How this motor is rotating at 800 rpm, and I wish that this needs to should rotate at 200 rpm. So 800 to 200 it needs to be reduced. So the gear box will implement or there will be a combination of gear, so that 800 rpm of the motor can be reduced to 200 rpm. Okay, so that is the that gear ratio R is the R. And this portion comes from the microprocessor that is available in the CNC system. So if N is the bit storage capacity and A is the entire length that we like to cover, so from that point of view, resolution can be calculated by N minus 1. Now usually what happens? A comfortable in the today's world, microprocessor bit storage capacity 32 64. So to the power 64 means exorbitantly large number, and usual value of what could be the answer? 1 meter, 2 meter length. So 2 meter and 2000 millimeter by 2 to the power 65 will be something around 65,000 or 35,000, something like that. So anyway, that figure, this ratio will come to very significantly small. Whereas this will come, we take the reasonable value, maybe 0.05 or 0.5 or 0.02, 0.15, depending on the values. So this is much higher than this. So ultimately, system will have only one resolution. Okay. So eventually, the max of these two is taken care of. Accuracy is a statistical part. What this is what exactly is called control resolution. This control resolution by 2 plus 3 sigma. If I go for illustration, it will take a little more time. One part is why I have taken CR by 2. So there are accuracy means what is the maximum level of error. Now there are two sources. One is due to this resolution and another part due to mechanical system error. How the resolution error will come? That's why I will give you a simple example. So we board কথা বলছিলাম স্টক আছে হ্যাঁ স্টকটা ওই আমাদের ফোনের পাশে আছে all should be equal. How is that a simple scale of 6 inch centimeter, 6 millimeter, whatever it may be. There is no further calculation in between 0, 1, 2, 3, 4, 5, 6. Now, if you are told to take a measurement of 3.56 or 3.4 or say 5.9, what will be your reading? Just take any value 3.4. See, if you take 3.4, what will be your reading with using this particular scale? The middle of the middle, there is no graduation. 3. So you have to be satisfied with 3. If it is 3.7, 4. So that means with this particular scale, there is some error. In this case, it is 0.4. In this case, it is 0.3. What would be this intermediate value between 3 and 4 for which the error will be the highest?
3.4.
3.5 people died. Maximum. So if it is 3.5, someone can be told that this 3, there is 0.5. If you satisfied with the 4, then also there is 0.5. So the mean value is the source of maximum error. With the same logic, so in this particular scale, 1, 2, 3, 4. So resolution is 1. In any fraction part is not shown, there is no such calculation. So if it is 0.5 is your maximum error, so in terms of resolution, 0.5 is how much? Basically half. That 1 is basically resolution. So it is resolution. So that is what control resolution. So this is one part of error. Another source of error comes from the mechanical movement. Like frictional movement, like wear and tear, like thermal deformation, all eventually contribute to some mechanical error. Now the difficulty is that these error do not follow any particular norm. For any particular movement, if we repeat, it may not have the same magnitude. So that is very difficult to quantify. But one thing is visualized, or one thing is eventually concluded that all such errors follow normal standard distribution. So if you take all the accumulated error, you will follow this standard normal distribution. And within this plus minus 3 sigma limits, 99.67% error can be captured. So within plus minus 1 sigma, 34.1 inside, another 1 sigma, 13.6, another 1 sigma, 2.1. So almost plus minus 3 sigma, printer 100% error can be captured. So that is why this 3 sigma. Now you can also understand why it is not plus minus. If I take minus, it may so happen for some value CR by 2 plus CR by 2 plus CR by 2 and minus sigma cancels out some bit of 0.5, bit of 0.5. Although both are present, but eventually algebraic sum shown as if system has got no error. But the accuracy always should be considered what is the worst case. So in that is why there minus sign is found. So combining mechanical error and system resolution error, entire accuracy is. And last term is repeatability. Quite often it happens. Suppose a particular program I am executing, get minus 50 or x 40 for several jobs, several times. And if you take the final measurement, sometimes you find 40.1, sometimes you find 40.0, sometimes 49.97. So the ability to repeat a particular command several times is known as repeatability of the system. How accurately it can repeat a particular command when it is executed several times. So in that case, there will be no change in the magnitude of the program. Same value, 40, 40 remains same. So CR part will not contribute. Only thing is that mechanical movement. So that is why repeatability is only the statistical term plus minus. What I was talking about, I am not going to the detail. The number of pulses required corresponds to a length that can be expressed by distance. That means in our program, if we write a x40 movement, system will MC will calculate what should be the total number of pulses which will be needed to be sent to the stepper motor for achieving that target. And this is the pulse frequency. Total number of pulses related to the displacement and pulse frequency is related to the velocity. Okay. So this is only for theoretical purposes. Component wise, we will have a part program, one program input device, MCU I have already told, drive system, machine to get the physical machine part and feedback device. This is what actually constitutes. The same thing with the exploded view. are shown. One is DPU, one is control loop unit. So functions of DPUs are read coded instruction and decoding, implement interpolations to generate axis motion commands. Generate axis motion commands to the amplifier circuit for driving the axis mechanism. Receive feedback regarding position and velocities from transducer. Implement auxiliary functions such as pull and on off, speed on. Okay. And this is CLU. So whatever commands will be coming from the data processing unit, that will be executed by the controller unit. So execute the motion commands. Feedback signal of position and speed for each direction is sent to DPU for calculation and onward step, and implement auxiliary functions such as speed on off, pull and on off, change. These activities come under the miscellaneous one.